So here we go. I can start it back over. If we have sine x being rotated about the x-axis here, took a cross section. When we rotate the cross section around, each one of those would form a circle, which would be pi r squared. So we're talking about pi from 0 to pi of sine squared x. But again, we can't do u substitution here. So we got two facts that we know. We know that sine squared x plus cosine squared x is 1, which means that sine squared x equals to 1 minus cosine squared x. So this is the first fact. The second fact is we know that the double angle identity for cosine of 2x is cosine squared x minus sine squared x. Now, with that, what we do is we say, okay, where I have sine squared x here, I'm going to substitute in 1 minus cosine squared x. When I do my arithmetic here, I get 2 cosine squared x, and then distribute the 1 in, so it's minus 1 equals cosine of 2x. All right, pull the 1 over here, so now it's 1/2 plus cosine 2x over 2, dividing both sides by 2 also, equals the cosine squared of x. Now we go back here and we know that cosine squared x would equal to 1 minus sine squared x. So I'm going to write 1 minus sine squared x where I used to have a cosine squared x. Pull my sine squared x over to the left side, make it positive. Subtract 1/2 from 1 and I still get 1/2 here. And then it's minus the cosine of 2x over 2. So now my new integral here, instead of being sine squared x, it's pi from 0 to pi of one half minus cosine of 2x over 2 dx. And from that, I can factor out a 1/2. So pi over 2 all right. Now, I could do a little bit of a u substitution here. I can let u equal to 2x. So du over 2 would equal to dx. So I end up with pi over 4. No, never mind, because I got this 1 here, so I'm not going to be able to just multiply out like that. Let me split this into two integrals. Or let's not worry about changing the limits of integration around. Let's just use this in thinking about what's happening here. So we got pi over 2 from 0 to pi of 1 minus, you would have the 1/2 associated with this, so it becomes the cosine of 2x over 2. Or I'm sorry, let's do that after we do the integral. So the derivative of cosine, negative cosine, would be negative sine, so it's negative sine 2x over 2, because it would be 1/2 of that. All right.
Don't have to do u substitution.
Oh, didn't have to. I just implied it in with it. So we're still going from 0 to pi. So we've got pi over 2.
Wait, why wouldn't you change the 1 to an x when taking the antiderivative?
It is, thank you.
Why
1 doesn't
is
become
there a
x.
dx after you're taking the integral?
Say that again?
Why is there still a dx after you're taking the integral?
Because I had it up there when I erased it earlier. Thank you for catching that too.
You're
All right.
welcome.
So this becomes the sine of 2 pi over 2 No, I've already plugged those in. And if I plug in 0, I get 0.
Why are you dividing sine 2x by 2 if you've already factored out the 1/2?
This 1/2 came from here. This 1/2 here comes from taking the antiderivative of the sine of 2x.
Do you mean cosine of 2x?
Thank you. So if u equals to 2x, du over 2 equals dx. So it's 1/2 of the integral of the cosine of u du, right?
So then it's 1/2 sine
So it's 1/2 the sine of
2x.
2x. So that's where I was getting that from. I just did that little bit in my head. All right.
Wait for me,
I will.
I can't see the, this.
So we end up with pi squared over 2, and of course this would be 0. So pi squared over 2 is going to be the correct answer here.